previous one, but the process, the steps are going to be almost similar. Okay, so we already have the fundamental theorem of calculus that helps us to evaluate the definite integrals. Okay, looking at this here and trying to evaluate the integral for this function, obviously we can see that this cannot be, we cannot like directly write the antiderivative for this, so one has to use the some sort of method, and in this case we are going to use the method of substitution. So let us start by using the method of substitution, and then we see what else we need to do in order to evaluate this integral. So using the method of substitution, you know, the first step is to start with saying let u equals to, and obviously the first step should be to use u as a function which has like an exponent, or which is a little more complex. And obviously this is more complex here and it has an exponent, so I'm going to use 2x squared minus 2x as my u. And then step 1, then step 2, that's step 1. In step 2, what do? We take the derivative of this function with respect to x, so du over dx, which is going to be 4x minus 2. And then we solve for dx, right? We solve this guy for dx, so dx will be, guys, I'm skipping that step. You already know you have to cross multiply and all that. So dx will be du over 4x minus 2. So I'm going to put that in a circle. Of course, this in the circle as well. Then in the step 3, we got to bring it all together. Now, here you have to do some extra work. Guys, this original function was all in terms of x with respect to dx. That means these values are also defined for x. X goes from 1 to 2, lower limit 1, upper limit 2. But now we are changing the variable from x to an u, right? So if we are changing the variable from x to a u, then we also have to change these numbers are also, the limits are also going to change. So what does that mean? That means if x is 1, so this is like x equals to 1, and this is like x equals to 2. So if x is 1, then we'll have some value for u, the lower limit. So I'm going to say u subscript L. L would stand for the lower limit because we know 1 is the lower limit. So how do you calculate u value for u as a lower limit? You just substitute x equal to 1. That is the extra step that you have to do in this case. Guys, in example 1, there was no need to do this extra step because we did not really change the variable. It was an x, we simplified it in x and we evaluated everything with respect to x. But here we are changing it from x to u and dx to du. That's why we have to do that extra work. Sometimes students forget to change these limits and then they get the wrong answer. Guys, I remember myself being a student of calculus way back when. I would sometimes just forget to change the limits. And then, I would lose some points on my quizzes or the tests. So please be careful when you are using a substitution method where you change the variable from x to u or something else. You also have to change, the lower limit and upper limit is also going to change. So the lower limit will be this value for u when x is 1. So I substitute 1 here and 1 here. So 1 squared is 1, 2 times 1 is 2, 2 minus 2 basically is just 0. Okay, that is the lower limit. Similarly, we got to find the u upper limit. For upper limit, now you have to substitute the x as 2, right? And when you do that, 2 squared is 4, 4 times 2 is 8, 8 minus 2 times 2 is 4. So it's basically 8 minus 4, which is just 4. So the lower limit and the upper limit are different now. It's 0 to 4, okay? That takes care of the lower limit and the upper limit. 2x minus 1, well, I cannot do anything with that right now, so I'm going to rewrite that, and I'm going to expect, I'm sure you have been doing these substitution problems, and at this point, you already know that you expect the x terms to cross out. Guys, most of the times they will cross out. I showed you an example where they would not cross out, then one has to use go back to number 1 and see how one can use that to kind of substitute back. But most of the times they will cross out. And let's hope that they cross out here as well. Now then we have the next one, which is e to the power, this whole thing 2x squared minus 2x, but this can be replaced by u right away. So we are going to replace that with u. We got that piece, then dx is just simply du over 4x minus 2, but 4x minus 2 can be simplified or written as a product of 2 because they have a common factor of 2. I can pull that out, and then what I'm left with is 2x minus 1. Guys, if you can take out a factor or the greatest common factor, or you can factor something, we got to do that, okay? Now, let's see what happens here. Well, there's this upstairs and this upstairs, and as we were expecting and hoping that we will see terms that we can cross out, especially the x terms, because we're converting everything in terms of use, so x terms better cross off, or we better get rid of those x terms. So this and this crosses out, and let's see what we are left with. Now from here we have 0 to 4, and then we simply have this 2 in the denominator. So I can take this, actually I can take that 1/2 outside. Okay, I can take this 1/2 outside, and that's what we usually do with the constants when we are finding the integrals, even with the derivatives. When we are trying to find the derivative and there's a constant times a function, we just take out the constant outside, and then there is e to the power u du. Now this is pretty simple. We already know how to evaluate the integral of an exponential function. So what is this going to be? Guys, don't forget there's a 1/2 outside. And then if you don't like to draw the curly brackets, you can draw a square bracket. You can just draw your regular parentheses. It's up to you. I like to draw curly brackets and square brackets, so I like to use different types. So guys, integral of this, first you find the integral of this, which is what? E to the power u. Integral of an exponential of the form e to the x is just e to the x. And then we don't have just a plus c here because we have the lower limit and the upper limit. We know we just, as a notation, we put the upper limit here and lower limit here. And then once we get it to this form, then it's all about using the fundamental theorem of calculus, which simply says use 1/2, and then you have to first substitute the value for the upper limit, so e to the power 4 and minus e to the power the lower limit 0, right? Which is going to be 1/2. We know e to the power 0 is 1, so it is simply e to the power 4. Let's get rid of that. e to the power 4 minus 1. You can leave it like this, or if you want, you can also distribute this 1/2, so it will be 1/2 e to the power 4 minus 1/2. So guys, it's up to you how you want to leave the final answer, but these are the steps for this particular example. This was slightly different than the previous one. The only difference here was that when you change the variable to a different one, you have to also change obviously the limits are also going to change, okay? So limits change, and then from that we can use the fundamental theorem of calculus to finally obtain or evaluate the integral, okay? This is example 2, guys. I will see you in the next video with example 3, again on evaluating definite integrals.